Welcome to this session on Google Cloud VMware Engine. During this session we'll clearly discuss Google Cloud VMware Engine, but we'll also have a closer look on how Google Cloud VMware Engine customers can take advantage of other services provided by Google Cloud, especially in the area of machine learning and petabyte scale analytics. My name is Wessel Gans and today I'm joined on the call by Slava Vladiszewski. While this is a recorded presentation, chat is live. So if you have questions, both Slava and myself will answer them in the chat. So please post your questions during the session as it's a live chat support for this session. So how can customers actually take advantage of petabyte scale analytics and Google Cloud VMware Engine? In order to go there, I wanted to have a closer look at Google Cloud's mission, right? Accelerate every organization's ability to digitally transform and reimagine their business through data-powered innovation, putting data at the center. When it comes to Google Cloud, we recognize four main areas for our customers to interact. So clearly, we're looking at the data, right? Data is an essential ingredient for all global businesses, and it is the rocket fuel for business transformation across analytical and transactional applications. Once generated, it powers deeper AI-driven business insights, helps companies make better real-time decisions, and it's also the basis for how companies build and run their data-driven applications. This is the heart of the data cloud that's emerging, to unify data across the organization. The discussion has evolved from why cloud to which cloud architecture. The vast majority of organizations will use a combination of clouds and open source software, rather than rely on a single service provider or closed technology stack for their needs. An open cloud transforms the way they operate their business and instilling freedom in how they innovate and drive differentiated customer experiences. A transformation cloud is just not about technology. Equally as important are people and culture. Customers understand that a successful transition into this new era of work hinges on how they keep their people engaged, productive, connected, and create new ways to serve their own customer needs. This is our ambition with Collaboration Cloud powered by Google Workspace. At Google Cloud, we help defend your data against threats and fraudulent activity using the same infrastructure and security services we use for our own operations, empowering you with the advanced capabilities that would be unavailable to all but the most well-resourced organizations. As enterprises move into cloud, they seek to take advantage of what Google has learned and apply it to their core security concerns. Enabling safer access, simplify secure access to services for employees, contractors and customers, protect against threats, create visibility needed to find, analyze and resist threats at the scale of your business, and own the strategy. Take advantage of cloud innovations while meeting sovereignty and governance requirements and maintain control of their digital assets. Moving to this cloud world might impose challenges for customers, right? Compatibility, applications running in the environment, how are they interconnected? Are they compatible to run on a cloud? Also from an operational standpoint of view, there is the tool sets being utilized in the current on-prem or source infrastructure, but also the skills in your organization, right? Learning a new architecture, learning new technologies might impose a skills gap for the people in the organization. Different network and security models, also the processes in place to ensure proper auditing and compliance compatibility could be the challenges faced by our customers. And this is clearly where Google Cloud VMware Engine makes it easier to migrate to cloud. Google Cloud VMware Engine is a fully managed VMware environment running in Google Cloud and allows you to bring up the environment in a matter of minutes and bring your workloads to Google Cloud without major modification. In some cases, you can even move your workloads without shutting them down. So a live migration from on-premises using the VMware HCX technology into Google Cloud VMware Engine. It's a first-party service. It's sold and supported by Google, but the solution clearly is supported and verified by VMware in the back. And it takes advantage of the VMware Cloud Foundation stack. It runs a hyperconverged architecture and allows customers to benefit from standardized operations, compatible to on-premises tool sets and processes. Our customer-driven use cases, right? These are the main 4 categories we work in with our customers. It's either adding capacity to the current deployment or migrate entirely to Google Cloud. And as said, this could be incremental growth in Google Cloud, or this could be a data center exit with full migration of all workloads to Google Cloud VMware Engine. And with Google Cloud VMware Engine, you get the ability with global availability of capacity around the world in the various regions we offer, but also fast migration with VMware HCX without need to re-architect your VMs or re-platform your VMs. Disaster recovery or backup. We also see customers deploying their secondary DR or backup site in cloud, taking advantage of the similar tool sets they are using in their current deployment, like the VMware ecosystem, VMware tools like, or products like the Site Recovery Manager, but also vRealize Automation. Suite is also available with Google Cloud VMware Engine in the way that you can define Google Cloud VMware Engine as an endpoint in your on-premises deployment. But we also have backup products like our own Actifio, but also solutions from other partners like Zerto, like Veeam, Commvault, Dell EMC Networker. So there's various components which are often in use in on-premises environments which can be deployed on Google Cloud VMware Engine as well. And it's one of the unique capabilities or differentiated capabilities where we allow these type of solutions to be integrated with Google Cloud VMware Engine. Virtual desktops is also a well-known use case. We have verified architectures for VMware Horizon and Citrix. And clearly where the focus of this talk heads towards is the data or application modernization. Take advantage of our advanced AI and machine learning capabilities, more cloud-native services, but also take these technologies and start the business and cultural transformation of your organization. So quickly review, let's say, the migration to VMware Engine, right? So when we say ease of migration, it's really all about taking advantage of VMware Hybrid Cloud Extension, the software that comes with Google Cloud VMware Engine, which enables 3 ways of migration. Cold migration, migrating your VMs over by shutting them down and copying them and booting them in cloud. That's one thing. Another is warm migration, bulk migration, which enables mass migration of hundreds of VMs in parallel. And then there is even for VMs that can't even be rebooted and need to maintain operational, there is the ability to leverage layer 2 extension for your networks. So extend your networks into Google Cloud VMware Engine. And from there on, do a live vMotion of your VMs into VMware Engine. And then you can move your specific VMs into cloud without shutting them down. They maintain operational. And once in cloud, customers can lower costs, right? In the on-prem environment, we often see customers having the capacity deployed for supporting peak demand, right? In cloud, you can actually right-size your environment and benefit from auto-scaling or manual scaling and add capacity to your environment when needed, and either in an automated way or manual, and scale it down again when the workload doesn't need the additional capacity. So there's already the benefits from scaling up and down, the flexibility in the cloud economics from that perspective, plus taking advantage of the fact that VMware Engine is a managed stack. So upgrades, lifecycle management is taken care of, for example. Running in cloud is also very similar to how you would run such an environment from an operational standpoint of view in the storage or on-prem environment, right? So the same tool sets, the same skills, the integration into the automation and orchestration tools that might be in use, that's all possible. And in many cases, we also allow you to integrate backup and DR products with Google Cloud VMware Engine. Also from a security standpoint of view, taking advantage of the security controls and services we provide, but also compatibility with your online or your on-premises policies, if you will. And clearly, when it comes to innovation, It is something customers can start to adopt at their own pace, right? Migrating, exiting your data center, maybe on an accelerated timeline, could be a challenge, and therefore there is less time to adopt new services. But once in cloud and everything is normalized and runs as expected, customers can start to innovate, right? Adopting new services, additional services, once the application team or the business is ready for it. Some of the services like Cloud SQL is our managed SQL Server, MySQL or Postgres. Cloud Operations is the monitoring and logging system overseeing all of the cloud services, including Google Cloud VMware Engine. TensorFlow, clearly a machine learning platform, as well as cloud storage, BigQuery, the Petabyte scale analytics platform we'll have a closer look at. But all of these services can be adopted at your own pace, and we'll have a closer look from a data point of view, right? So an integrated data platform. We started out with this data-centered innovation, if you will, and this is the data platform customers can leverage and take advantage of, also in combination with Google Cloud VMware Engine. So there is 5 phases like collect, process, store, analyze, and activate or analyze your environment to push the data through the system. There's various managed services we provide to get the data into the system. ETL in the process, managed services we offer there, as well as to store it in 2 types of databases, as you can see here, as in NoSQL and relational databases. And clearly analyze your data in our petabyte scale data warehouse, BigQuery. Even BigQuery has machine learning capabilities built in, which you can actually access using standard SQL. Instead of being a data scientist, you are able to use machine learning capabilities directly through SQL in BigQuery. We'll have a closer look at BigQuery in a minute. And there's clearly the integration or feeding the data into AI platform, where various tools are available from that perspective, as well as presentation and dashboarding platform, Looker and other applications from third parties we can feed the data into. So what is BigQuery, right? I'm putting the numbers on the screen here, and just to give an impression of the scale of such a solution, and also have a thought around what it would take to run such an infrastructure. Right? The amount of storage, the compute power, the amount of infrastructure needed to be able to support this is quite substantial. And then there is clearly the software running on it, being able to distribute, for example, your queries across the various nodes in the infrastructure requires additional skills in order to tune it, to maintain it, to make sure it supports the data sets you're looking to analyze. Where I'm getting at is often when you deploy this infrastructure in the on-prem environment or in another environment, you would have to have a lot of infrastructure from a hardware point of view readily running for you. In addition, it requires a lot of skills to make sure the solution delivers the expected outcome when running the queries at the right performance, if you will. And this is where BigQuery, which is our serverless data warehouse, have a different approach. It's a fully managed service. It's a serverless data warehouse with, on the left-hand side, as you can see, ingest into the durable distributed storage, if you will, and on the right-hand side, the decoupled compute capacity, right? What this actually means is you store your data in the replicated durable distributed storage, and when you run a query against it, we will scale up the compute capacity as needed to complete the query as fast as possible. And BigQuery software will distribute the query amongst the available CPU cores to make sure we can complete the query as fast as possible. And as I said, this is a managed service, so it doesn't require the infrastructure to be running all the time because it's serverless, and it will scale up the infrastructure at the minute you execute your query. And from there on, you don't have to have all of the capacity all running all the time, because you use the capacity, especially from a compute standpoint point of view, at the time you execute the query and for the time the query runs, and after that you will not be charged for the compute capacity, for example. So With that, you really can go down to a price per query, if you will, when you leverage the BigQuery platform. This demo is a quick introduction into Google Cloud BigQuery. Serverless, highly scalable and cost-effective multi-cloud data warehouse designed for business agility. But how fast is BigQuery really? Google BigQuery has numerous public datasets that anyone can query. Let's have a closer look at the publicly available datasets from Wikipedia, which contain metadata about the web pages. I've selected the Wiki 100b, and as you can see, it's got 100 billion rows in there, and it's about 7 terabytes in size. We're going to run a query against this, so I open a query editor and paste the query here. And this SQL query allows us to see how fast we can scan and process 100 billion rows looking for the word Google in the Wikipedia page titles. But before going there, I would like to have a closer look. Earlier today, I ran this query already. I'm going to show you the job details. As you can see here, it processed 4 terabytes of data, similar like we're going to process now, and the duration was 25 seconds. So BigQuery distributed the query across many CPU cores and was able to finish the job in 25 seconds, and there was the resources been added to the bill. Now we're going to rerun the same query, and as you can see, it's again 4.1 terabytes that's going to be processed, but also have a closer look on the top right and the time it takes to complete the query. And as you actually can see, it will complete in about 3 seconds. And that's fast. 25 seconds was really that fast, but this is even faster. So how come? So if we have a closer look again at the query details, you actually see now the duration is 0 seconds, so there is 0 data processed. And this is referring and being possible by a feature offered by Google Cloud BigQuery. It allows you to cache queries. So if you rerun the same query again, there's no further delay of processing and there's no incremental resources being added to the cloud bill as the result of the query is served from cache. Now, if you would run a similar infrastructure on premises or in another environment, let's assume the software is similarly efficient as BigQuery, you would still need around 300 hard drives, a massive amount of network bandwidth, and 3,000 cores to be able to complete such a query in such a short amount of time. And now, when we had a closer look on what BigQuery is capable of, the performance, the capacity of the platform, how are we going to integrate this with Google Cloud VMware Engine? So on the left-hand side, you see VMware Engine. You've migrated your applications as is, your VMs, your databases, your application servers, everything is running on Google Cloud VMware Engine, and there are various data sources ranging from Oracle, SQL Server, other types of data sources are running in there. With minimal or no modification, they are available to be integrated into, let's say, a data replication pipeline, for example, which will get your data into Cloud SQL or BigQuery or any other service we might be able to replicate to. And in this case, we will be looking to integrate data sources on VMware Engine with Google Cloud BigQuery. We'll have a closer look at Google Cloud BigQuery in a minute. Cloud Data Fusion is a service which basically allows you to deploy code-free pipelines. And in this case, you can actually deploy a code-free replication pipeline from your MySQL or SQL Server data sources running on VMware Engine, which will replicate the data into BigQuery. There's another service called Data Stream, which, for example, also supports, in addition to these two, Oracle. So there's multiple of these solutions we have available to suit a variety of data sources, replicating into, in this case, BigQuery. In this demo, I'm going to deploy a code-free data replication pipeline for MySQL running on Google Cloud VMware Engine towards BigQuery. What you see here is the homepage of the Google Cloud Console. From here, I can access the services we offer here. But for this demo, I'm going to go straight into Google Cloud VMware Engine. What you see here is the summary page of a cluster, a private cloud with one cluster running in Europe West 3, our German region. When I navigate to the vSphere management network, you'll actually see the vCenter server, the NSX manager, and the HCX manager. It's a 3-node cluster, and it comes with GCVE specific name servers. I'm going to log on to this vCenter server and identify the VM which has MySQL installed. So my database is the VM. As you can see, I'm logged on to the vCenter server in West 3. The IP address ending at 225 is the one which is running MySQL. For the server which is running MySQL. I'm already logged on to this one, but just to show you the IP address again, so there you see. Now I'm going to log on to MySQL. We're here. We're going to have a look at the databases. So Classic Models and Sakila are two demo databases. We're going to use Classic Models. And from here, we're going to run a quick query against customers table. And when we move up, you'll see the various columns, customer number, customer name, contact last name, and those are the ones we will recognize once we create the replication pipeline using Cloud Data Fusion. And this is where we're heading now. This is the Cloud Data Fusion interface. There's multiple pipelines we can deploy. I'm going to deploy a replication pipeline. I'm going to deploy a replication pipeline from MySQL to BigQuery. I'm going to give it a name. MySQL to BigQuery. The source in this case is BigQuery, MySQL. For the host, in this case, I'm going to supply the IP address again of the VM. Plugin, the port it's listening on, the database name, Classic Models, the user, and that's a user I have already set up for replication prior to the demo. And you'll see the tables when looking at the customers table, which we just used for a query. We recognize the same columns again. So we're going to replicate all of the content of the entire database towards BigQuery. BigQuery is the target. It's very easy to configure because it auto-detects the project and it auto-detects the service account to use. I might have influence where I do want to locate the bucket holding the data, the cloud storage bucket, but I'm going to leave it at the default. It's a small database, so I have less transactions, so I don't expect heavy traffic, so it's less than a gig an hour. From here, we will be able to review whether the database is in a good shape. So if there's any connectivity issues, missing features, or other issues with the database, but there aren't any. So let's move on. This is a summary of what we're going to deploy. MySQL source, target is BigQuery, and this is the tables we're going to replicate. And from here, I'm going to deploy the replication job. And now we have a replication job pulling data from a data source running on Google Cloud VMware Engine and replicating it into BigQuery. Google Cloud VMware Engine is your fast track to cloud transformation. Fast migration to Google Cloud VMware Engine, take advantage of the toolsets that come with Google Cloud VMware Engine, cost effectiveness, managed service, larger node SKUs allow you to run at a higher VM density, offering a lower TCO per VM, but also taking advantage of the ability to right-size your environment and add and remove capacity as needed. Fast time to value, being able to continue to run operations similar to on-premises with minimal or no changes to tooling processes, and also take advantage of the skills available in your organization. And no risk transformation, right? So you can start to adopt newer services in your environment without major changes in your application environment, and therefore being able to start modernizing your application landscape. With that, we've reached the end of the presentation. We would like to invite you for a session on a more specific demo for your environment. Also, have a look at our free assessment tool in which you can actually have an assessment including application dependencies in your environment. And we're happy to have a session with you to review the findings of the assessment and see if we can define a plan forward together. With that, thank you for your attention.